Before we look at series and parallel circuits, I just want to review a basic circuit. So we'll look at a circuit with a light bulb and a battery. I'll add a switch in, and we're going to use this website, FET, which is an online digital circuit builder. And it's really handy. It actually helps us visualize what's happening to the electrons in the circuit. So it's a handy way to look at a circuit. So I'll just connect my circuit, and then I will switch it on with the switch. This is my positive end of the battery, and this is my negative end of the battery. We should see the electrons coming out of the negative end of the battery. I think that they're repelled from the negative end and that they're attracted to the positive end. So they'll come out of the negative end, go around, and come back to the positive end. And that is my electron flow. I can also come over here and see conventional current is the opposite because they didn't know about electrons when they set the current. So you can also switch to current flow. And current flow will come out of the positive end and go around to the negative end of the battery. So either of those work. I'll look at electrons for now. We will often look at conventional current as well. So my electrons come out of the battery. Just as a review, we're going to look at voltage and current. My voltage tells me how much energy the electrons are gaining or losing across a um, source or a load. So I can look at the source in this circuit, which would be my battery. And if I put my voltmeter leads on either side, it's going to tell me how much energy is gained or lost. And for the battery, it's giving the electrons a boost of energy as they go through. So they come to the battery, they get a boost of energy, and we have a voltage of 9 volts. So that means that they're getting like a boost of 9 volts of energy. I'm going to just switch over to a Jamboard to show this summary. So as the electrons go through the battery, they're gaining voltage. In my simulation, I had 9. Here I have 3 volts because each of these is 1.5. But in my simulation, I have 9 volts. Then what happens is they go around the circuit through the wires. And ideally, as they go through the wires, I shouldn't see them gaining or losing energy. So in an ideal world, my wires wouldn't lose energy. In real life, they will lose a little bit, but we'll assume it's almost zero. But when they get to the light bulb, they actually lose energy. And that energy goes, that electrical energy turns into light. So actually start with chemical energy in the battery. It converts 9 volts per package of electrons into electrical energy. The electrons carry that energy around to the light bulb, and then we lose that 9 volts as light energy. And again, this wire carrying the electrons back should have 0 volts. That's not gaining or losing energy. So this voltage is like how much is gained or lost. Let's just update my Jamboard and say ideally those electrons should lose no potential energy through the wires. But when they get to the light bulb, they lose their potential energy as light. And whatever I start with in the battery, I should lose that same amount in my loads. Here I just have one, so I'm just losing all 3 volts in this diagram. It's 3 volts at the load. In my simulation, I gained 9 volts and lost 9 volts. So they're not just losing a little bit and then getting another boost. They have to lose everything before they go back to the battery. The next thing I want to have a look at is the current. And I like to think of this as bumper to bumper traffic, or you could also think of it as water flowing through a pipe. The flow has to be the same. No more water can move behind the water in the pipe. It has to flow at an even rate throughout the pipe. Or this could be like bumper to bumper traffic of electrons. They have to flow at the same rate. When you're actually measuring ammeters in real life, we would actually put an ammeter directly in the circuit because it's measuring flow. It has to have that flow going through it. But I also like this handy um, ammeter that you can just hover. So when you're using your PhET simulation, it's quite handy to use this hovering ammeter. And you can very quickly find the current anywhere in my circuit. And you should notice that the current's the same everywhere because this is like bumper to bumper traffic. The electrons are flowing at the same rate everywhere. And I'll come back over to my Jamboard and just highlight that as well. So the electron flow has to be the same everywhere in my circuit if there's one path. The last thing that I wanted to talk about is resistance. So the load is where my resistance is at. So the light bulb here will resist the flow, and when it resists the flow, it can convert electricity into something else like light. A heater, like your toaster, would convert that electricity into heat. A motor would convert that electricity into movement. So whatever your load is resisting the motion of the electrons and converting it into another form of energy. And I'll just update that on my Jamboard. And your resistance, you can see in this simulation, if you click values, it'll put the resistance on. On my Jamboard, the light bulb is what is resisting the flow of electrons. A dangerous situation can be if you don't have a load, then the electrons aren't resisted, so they don't lose any energy, and they keep gaining more and more energy. They'll start to move dangerously fast and could melt the wire and start a fire. And you can actually test this out on the PhET simulation. You can just take a battery and connect it with two wires, and you'll see it actually starts a fire if you do that. And that's called a short circuit. And you can always just unclick it if that happens here. One thing that I do notice often is if you don't hook up your light bulb correctly, you get a short circuit. So if you connect just one, the light bulb has um, um, two terminals that you can connect to. If you connect to just one, the electrons don't go through the light bulb. They'll just go around it. So you have to connect one wire to one terminal and one to the other, and then you have it flowing properly. And that is a review of your current, voltage, and resistance in a simple circuit.